Hello, my name is Jonathan Okeke, a final year electrical and electronic engineering student at the University of Johannesburg, and I'd like to give you a quick demonstration of my final year project, which is an autonomous waste sorting robotic system. My autonomous robotic waste sorting system mainly consisted of two subsystems, those being the hardware subsystem and the artificial vision subsystem. The hardware system was comprised of the robotic arm that you can see here, which was made up of 4 servo motors, one powering the mechanical gripper and the other 3 for the 3 joints that made up the robotic arm. And these 4 servo motors that made up the robotic arm were all controlled by the Arduino microcontroller that you can see here. The artificial vision subsystem comprised of a single web camera mounted above and parallel to the workspace, and this single web camera was used to stream live video of the workspace in order to perform the necessary image and video processing required to complete the object detection and localization tasks. The actual object localization, detection, and classification was performed by an artificial neural network that was trained to detect the 5 main classes of waste, those being paper, plastic, metal, glass, and cardboard. And with that short introduction, I will now proceed to give you a quick demonstration of how the system performs at performing the waste sorting task autonomously. This demonstration will involve tasking the robotic system to correctly sort the 4 objects into their respective containers. We will begin with the piece of paper, followed by the metallic object, and then the piece of plastic, and finally the piece of glass. Finally, I'd like to give you an idea of how the artificial vision subsystem perceived the workspace, and more specifically how the artificial neural network performed the object detection, classification, and localization. The artificial neural network was trained using the TensorFlow framework to detect the 5 main classes of recyclable waste objects, those being paper, plastic, metal, glass, and cardboard. The object detection and classification involved placing a bounding box around the detected object with its predicted class label name as well as the confidence score of the classification performed. This confidence score, expressed as a percentage, was simply how confident the artificial neural network was at making said prediction. The object localization was performed by extracting the x and y coordinates of the bounding box edges in order to find the center point of the bounding box in pixel coordinates. These pixel coordinates were then transformed to real-world coordinates with respect to the robotic manipulator's base. Finally, these real-world coordinates were fed into the inverse kinematic model of the robotic arm, and the output was a set of joint angles required to position the mechanical gripper onto the waste object for sorting. These calculated joint angles were then sent to the Arduino, which then commanded the servo motors that made up the robotic arm's joints to rotate to said calculated angles. Following this, the sorting task was completed.